Welcome to St. Stephen's Indian School!
St. Stephen's Indian School is a BIA grant school situated on the Wind River Indian Reservation in central Wyoming. The reservation is home to nearly 10,000 Native Americans, mostly of the Northern Arapaho and Shoshone tribes. Students work hard on the usual subjects like math and English. We are very proud to be involved in this project.
NASA Connect asks us to show you how to do the lesson for this show. Here's how you can become real atmospheric detectives.
Once you've gathered the materials listed in the Educator's Guide, locate a specific outside area that is flat, elevated, and open. Divide the class into 4 research groups. Each group then tapes one piece of contact paper to the center of the cardboard. Tape the one piece of contact paper in the center of the cardboard with the sticky side up. Keep the protective backing on the contact paper. Repeat the above procedure for a total of 2 aerosol samplers for each research group. Each group is then assigned an area on the school grounds in which to place its sampler. Each group completes the morning column on Table A, Observations of Weather Conditions, on Student Data Worksheet number 1. You'll need to refer to the local paper, watch the local weather report, or visit www.weather.com before completing your observations. Now place one of the samplers on a flat surface, preferably a meter or 2 above the ground. Remove the protective backing from the contact paper. After exposing the sampler to the outside air for at least 2 hours, place the aerosol sampler grid side down, over the contact paper and return the sampler to the classroom. Using a magnifying glass, or holding the contact paper up to a light, count the number of aerosols found in each of 10 randomly selected squares on the grid. Randomly select the squares by tossing the dice twice. Record the number of aerosols in each sample square on Table B, Aerosol Sampler Collection Data, on Student Data Worksheet number 1. Add up all the aerosols in the 10 randomly selected squares to get a total. Next, divide the total number of aerosols by 10 to get an average or mean of the aerosols per square. Repeat the procedure for the afternoon samples. After the average number of aerosols per square for each of the 2 samplers has been calculated, construct a line graph using the aerosol sampler line graph to compare the data. After you've completed this activity at school, you'll take your own sampler home. Place your sampler on a flat surface 1 to 2 meters above the ground. Leave your sampler outside overnight. First thing in the morning, attach the aerosol sampler grid side down, to the contact paper. Bring your sampler to school with you. When you get to school, your teachers will give you time to randomly select your 10 squares. Find the average and record the data in Table C, Aerosol Sampler Data, Collection from Home, on Student Data Worksheet number 2. Next, you'll write your address and the total number of aerosols from Table C on a self-adhesive note. Your teacher will divide a map of your community into 4 regions: Northeast, Northwest, Southeast, and Southwest. All students will place their labeled adhesive notes onto the map where they live. Using the data from the map, find the average for each region and make a class graph of the data.
Analyze your data, guys. Now that you have the results from your sampler, you should review the data and discuss your observations. Then, consider these questions. How can weather conditions affect the results of this activity? What are some other methods you could use to collect data on aerosols in the atmosphere? Look at your map of your community and the data collected from home. What is the relationship between where students live and the amount of aerosols collected? Teachers, check out our NASA Connect website. From here, you can download the Educator's Guide, where you'll find more questions like these that'll help your students analyze their data. Now, let's head back to Hampton University and meet Dr. John Anderson. Dr. Anderson uses space-based passive remote sensing to measure aerosols in the atmosphere. Remember, this type of remote sensing is different from LIDAR, which uses active remote sensing to measure aerosols. Dr. Anderson's passive remote sensing system is actually above us right now, on a satellite in space. A satellite is any object that orbits another object in space.